Hello, everyone. This is Priya Sarathy's and another edition of the IEEE nominee webinar. So I'm happy to say that we have a wonderful program or discussion in front of us because the work of the four people who actually undertook this a nomination on airline pricing is simply very intriguing and very interesting. Yeah. So let me introduce myself. My name is Priya Sarathy. I am a current board member of the Analytical Society of Informs. I'm also the chapter president for the Atlanta Inform Society. And with me today is Shiva Subramaniam from IBM Watson. Before we get to the introduction of Shiva, I would like you to introduce yourself. Let me talk a little bit more about Informs. So Informs is one of the largest professional associations for data and decision sciences, and its members work in the area of maths, scientific methodology, in different applications of AI, decision sciences of different categories, because it has really grown over time. And most of all, the members are involved in helping different organizations, government agencies, and communities to use and apply analytics and data science to make a meaningful impact on them. Informs is also one of the largest professional and student membership in the world. It has about 2,000 plus members. And each member, as I mentioned before, are trying to make a difference using data, information, and insights to save lives, save money, and solve problems. So today, one such problem that we will be solving is about airline pricing. So I'm going to share my screen so we have a sense of who we're talking to. So let me get this going. Share screen options. Sorry. Okay, so you should be able to see my screen. So yep. The IEEE is an award that's given annually at the Analytic and Business Conferences, and it recognizes the creative and innovative application of combined analytic techniques to create economic and social value. So previously, we featured a team that came from the University of Ottawa and also the Human Milk Bank in Ontario. And that was the discussion topic was on optimizing milk pools at the Roger Hickson, Ontario Human Milk Bank. So today, we are discussing AI-driven policy generation for dynamic pricing of airline ancillary. So Marcus, unfortunately, could not attend. He was ailing the earlier part of the day. So we will be looking at Shivaram Subramaniam to help share the insights around this work. So while I switch the screens, could you introduce yourself and tell us a little bit about your background, your role in IBM Watson Research, and how you got involved with this project?
Sure. So first of all, thanks for giving us this, pretty awesome opportunity to kind of, present our work once again after the IEEE presentation last year. So I am part of the IBM TJ Watson Research Center out in Yorktown Heights in New York. So I'm kind of representing my team here, which includes, Marcus Ettel, Wei Sun, Yusuf Drissi, and Zhengliang Zhu. So we're all part of IBM Research. We've worked in a lot of different areas, primarily kind of combining machine learning and operations research, kind of bringing those skills in and solving a variety of, practical problems, industrial as well as, otherwise. So my own background is that, I started off in the airline industry, incidentally, which was very helpful here. So I worked there for a few years and then worked in the retail space before joining IBM about 14 years ago. So since then, we spent a lot of time working on retail pricing problems, in particular in the last few years. before this kind of interesting problem from the airline space, came to us. So that's kind of just a very quick background of, how we got here.
Okay, great. I know Marcus also worked with you, and there were two other people
Yes.
that I shown on the screen that also were the team that applied for the award
Yep.
application as well.
Yep.
So while we are on that main page that I'm sharing, could you get us started about how did the problem come to you, or were you already working on that problem and then it seemed to be a match for something that the customer was seeking? How did that transpire?
Yeah, it's kind of interesting. So, the airline client was kind of one we have IBM has partnered with for a very long time, right? So they were grappling with this specific problem on, how to kind of move away from kind of the static pricing that they were currently employing for ancillaries, and we'll get to what ancillaries are in a moment. But they had their own team and they were kind of doing all this stuff. And airlines typically work with inventory controls where they're opening and closing fare classes, and they're pretty good at that. Like I said, we were working in the retail space where we were directly kind of playing with the pricing rather than inventory controls. So we were kind of in the pricing control space. The airline is kind of roughly in the inventory control space. So they tried kind of their thing. They had a very competent, data science team. And, they were able to, get some improvement kind of when they tried this stuff on their own. But there were a lot of kind of some technical issues that made this problem kind of quite challenging. So they kind of, invited us to come in and take a shot after they saw one of our presentations that we had made on kind of the pricing problems that we were solving. They felt, maybe that might, do a better job. So that's kind of how we got started.
So, yes, so you were going to go towards the description of the problem. So let's kind of start with that. Two words that I'm not quite familiar with, and maybe even some of our audience may not know, is what do you mean by ancillary pricing? I think in this case, I have the slide that you wanted me to share, so I will put that up as well.
Yep, I think just the picture, the
Yeah.
title picture, I think kind of
Okay.
shows
Okay, great.
whatever we're talking about. But typically, it's kind of anything other than the kind of the core product that they're selling. For example, in the airline case, it could be a main cabin seat as kind of the core, and ancillaries is kind of anything on top of that. So it could be, in this case, you might be upgrading to a higher class or a different cabin. You might offer some discounts on prepaid baggage, lounge passes. So there's kind of wide variety of products, which the airlines, if anybody who's traveled has kind of seen that it's all kind of you go through a series of pages and you kind of see prices for everything. So all of these kind of are ancillaries that the airline is selling. So that's kind of.
So would it be okay if I kind of related that to from my marketing days to
Oh,
more of
absolutely.
cross-selling and upselling across the different price points, across additional supplementary or complementary services and products?
Perfectly put. Yep, absolutely.
Okay.
Yep.
Okay, so that gives us an idea. So that's where we can kind of think about. So the pricing is about how would you make that price offer to your customers saying you want to upgrade to a launch. What is it that you're going to charge for that to happen? So, okay, let's kind of continue because I think that sets us a grounding of it. So you are using some aspects of dynamic pricing optimization. This is some work that has been a very strong part of optimization going back over time. In manufacturing has used different types of optimization and then product merchandising. So what is it about the dynamic pricing? What are the key components or pillars that you are kind of using and leveraging to move your research in this area forward?
So primarily we are driven by kind of the customer needs and satisfy the requirements, right? The business requirements that they kind of give to us. All right. So we have to work, within that kind of framework and the constraints that they have, right? So the first and foremost one is, of course, right, transparent, non-discriminatory pricing.
Mhm.
There's been a lot of work, for example, in personalized pricing. You see plenty of journal papers on that. And yes, I think depending on the domain, it can kind of give you fantastic results. But there are other cases where it's got pros and cons, right? So it can lead to kind of issues of discrimination, other things. So the client was very particular in that. Okay, we don't want to do that, right? We want to be very clear in that they wanted a solution that was very transparent. It had to be interpretable, and it's not working with any kind of personal data or anything like that, right? So those were kind of
Mhm.
the requirements they had upfront. So that was one thing. And of course, the other challenges that come with the airline is that, like I said, they have the very static pricing policy before. Maybe they do some manual changes seasonally. But the
Mhm.
moment you start going to dynamic pricing, right, it can have cascading effects, and you kind of have to be careful on how you do that. And that was actually one reason why they kind of were, kind of sticking to their standard kind of static policy. So, we had to come up with something that was more dynamic and handle all the, manage all the effects that come with that, and kind of make sure you satisfy all those requirements.
So I heard three things. So I heard the fact that they had managed and they had somewhat in a static reactive manner responding to the market and changes in market behaviors and all that.
Correct.
So you
Correct.
kind of made a move that take that pricing models and show them how to make it more dynamic, more inclusive of those behaviors that may be changing, of any kind of available information that has been got updated in real time may have an impact on how you do pricing. Okay.
Correct.
And so the transparency, I think that was one of the key things because
Absolutely. Yep.
there's a lot of talk on regulations and things like that. So those
Yep.
were the three. Okay, great. So that gives us a idea of how you were taking the problem and you were adding more constraints that had to be looked into and woven into your methodology and approach that you have already had some notion about.
Correct. Yeah. Just to add a point here
Yeah.
is, right. So they have an existing business process that
Mm-hmm.
they cannot change for this, right?
Mm-hmm.
So they still need to have all their inventory controls, and that just keeps working. So
Mm-hmm.
we have to find a way of fitting this solution to work seamlessly with what they already have.
Yeah.
So in some sense, you can think of this as it's dynamic pricing, but it's like a proactive pricing control that dovetails with their inventory control kind of.
Yeah, so making those things streamlining, and that's
Yeah.
extremely hard because you're solving
Yes.
for one area, and then it's like taking the square
Exactly.
block and putting it into the round hole, or the other way around is.
Yes.
So did you have interactions with them? So were they part of your team while you were, I would say,
Yes.
retrofitting what you had as a pricing model to their
Correct.
needs?
Absolutely. Yeah. So, we would meet with them weekly. Their data science team would be there. We'd kind of review the results together. And, they were able to give us a lot of good insights on, okay, this market, maybe this is not how it should be, or this seems to be off. Right. So it was always a very, very collaborative effort in that we kind of had weekly checkpoints. So always kind of worked with them, kept reviewing, iterating, right before we kind of slowly got to a point where, they had a clear understanding of, what the outcomes are, what kind of methodology we are employing, what kind of data is required, and what kind of cadence this should be applied in. So all those kind of nitty-gritty details were all kind of ironed out
Mm-hmm.
over the span of the project.
Okay, so while I was reading your presentation, couple of things that came to me, and I was like, I need to kind of understand what this is. And I think you've done a good job in your paper. But before we go into what work that you actually did, I think it is fair to say that you used to explain using counterfactual based interpretable models
Yeah.
that they offer a better alternative in solutioning the solution that you built.
Right.
So could you take a moment to help us understand what you mean by counterfactual in regards to this problem that you are solving, and how did that actually become valuable in the solution that you developed?
Okay, great question. I think maybe it'll be better if we kind of take a concrete example.
Yeah.
So you're part of kind of heading the Atlanta chapter. So let's say there's a flight from Atlanta to Dallas, right? And then there are multiple cabins. Customers going to the airline website and right, even though okay, this shows a JFK SFO, but I think we like
We'll
Atlanta.
assume it. It's
Yeah,
yeah.
we like Atlanta and Dallas,
Yeah.
right? Uh, so the customer goes to the website and they can see all the various prices. So they can just get a main cabin ticket at whatever price. Then the pictures that shows with the ones with red arrows kind of shows I think you use the term upsell, which is great here, right? So what is the upsell increment that maybe a customer can pay if they want to upgrade, right? To maybe to business class or economy premium. There could be like several options. So what we are doing here is in this particular example, is to figure out how would a customer respond, right, if we made them this offer, right? Now they go to the website, they see a price, right? It's always one of these. But what we do not know when we look back is maybe the customer accepted it or they rejected it. But we don't know what would have happened if we had showed them a different price, right? Or a whole range of other prices. So that is where the counterfactual comes in. So it is typically, in a very simple sense, it is a what if. So what if I had offered some other price, right? What would the outcome have been, right? But unfortunately, that is not available in the training data, right? So sometimes the possible range of actions or the prices you want to offer may include prices that you've never seen before. You may have to extrapolate, right? Uh, what happens if I do that? Well, I have to take care and kind of price with care. If I have two products, I don't want to cannibalize one and kind of, hurt my sales for the other. All these complexities kind of kind of come about, like I talked about the cascading consequences. So the counterfactual really is this doing a what if analysis, right? And then that becomes a starting point for the rest of our pricing procedure.
So
I hope
that
I,
would,
I hope
yeah.
I,
So yeah, so that is actually like you're thinking ahead. So you are kind of envisioning what your scenarios are going to be ahead of you solving a problem specific to that, because
right,
obviously you don't have the facts.
correct.
And it could go counter to the facts that you have, but you have limited facts, and we assume that that is not a complete from solving the problem. So
Yes,
you're
that's
anticipating the scenarios. Now, how did you kind of grasp what these scenarios are? I know you told me you work closely. How were they able to kind of give you the right information to think about and design these business, I would say, rules or
right.
assumptions that you had to make?
Yeah, it was challenging, right? Because they had primarily a static kind of baseline price, right? Which means that there was very little in terms of price experimentation in the historical data, which allows you to kind of learn the sensitivity of prices to your customer response, right? Uh, so we kind of looked literally at millions of such data points, right, across a wide variety of markets, right? So that gives you an idea of, what is kind of a safe range that you want to start with. Maybe initially you start with letting your counterfactuals, maybe vary by, I don't know, right, plus or minus 10% or 20% compared to the baseline. And the hope is that you make these offers, you handle all the effects that come with these offers, and then you look at the customer response. So there's a little bit of kind of learning involved here, which means that you have to kind of do these. It's a bit like A/B testing,
Yeah.
right? Which you're very familiar with, I'm sure, right? So it's a bit like A/B testing, yeah. Except yeah, it's kind of I would say roughly, it's kind of you go along that path
Okay.
and kind of learn from there.
Okay, so good. So we kind of said a lot of background to this. So now if we go on to the methodology and how you kind of train this model for, policy learning, so how did the team design a model to ensure both, on one hand, to be transparent and the other hand, to be accurate as well? So how did that methodology evolve to take care of these two critical pieces?
Yep. So like I said, we have, folks with several different skill set in our team, right? So they were, machine learning experts. There were people who were very familiar with working with large volumes of data, operations research, obviously, right? So it was a mix, statisticians. Uh, so there are two pieces to our kind of solution approach. One is what we call a causal teacher or a predictive teacher model. And then there is a prescriptive student model. So the causal teacher's job is to take all your historical data, right? Millions and millions of data points. And then it goes through a lot of kind of machine learning kind of steps. Ultimately, it is a causal inference kind of an engine, which is generating a wide counterfactual grid of prices. Let's say for, again, take going back to our Atlanta, Dallas market. So it knows, okay, historically, this is the kind of rough price range that was offered for an upgrade. So it's generating a range of prices in the vicinity of that, right? 10 to 20%, right? And it is also predicting the kind of the probabilities, right? How likely is the customer to upgrade at this price, this price, this price, whole range of prices. And that now becomes the output to our student model, which is the prescriptive part.
Okay.
Now, for a solution to be kind of very interpretable, I think we looked at what kind of options are there, and one of the requirements from the customer was that, okay, ultimately, in at least for some of the ancillaries, it has to be published, right? Which means that you literally have to give it to them in the form of some kind of rules, or it has to be ready-made. It's not like a engine that you can plug into their system. So they have to give it, you have to give it in advance to them, and they have to publish it, right? So that made a decision tree structure kind of a very natural kind of format, because it's very easy to read. You can generate rules out of that, and you can clearly see what are all the factors that are involved. So the student model is taking these counterfactual what ifs, and it is simultaneously determining the different segmentations within the different customer groups, like predominantly business, predominantly leisure, and noting that these things change over time. So it has to have a look ahead policy as well. So it's doing all of this, and at the same time, it is figuring out the prices for these segments, right? So it's kind of doing this thing jointly, in that your rules kind of synchronize with the prices synchronize with the rules. When I say rules and segments are kind of interchangeably used here.
So you had a team of 4.
Yep.
How did going through these 3 layers of methodology, how did you kind of distribute and share? I mean, was there a specialization that each of your team members brought to the table, or it was like assignment of, hey, this is something we can do, and whoever wants to do it, do it? How do you kind of decide? Because this is a complex layered problem.
Correct.
And they all worked with each other, because anything that happens in the causal or the predictive teacher layer is going to have an impact on how the prescriptive student approaches are going to be responding and generating the policies. So how did that synergies of the team work out to achieve the goals you had in mind?
I think that's a great question, simply because it's also related to our design itself, right? So the student model is kind of agnostic to the choice of your teacher model, right? So because you're only communicating the language of just counterfactual data, right? You aren't taking, for example, any model parameters and kind of implementing that, putting that entire kind of prediction model in some optimization or prescriptive framework. So which means that you can have kind of, two of us are kind of focused more on kind of the predictive part, right? So there's one person who's building it. And, for example, Wei-Sun is like really good with causal inference. She's done a lot of work in that area. So she's kind of giving it a once, so, checking and making sure that, it's kind of behaving properly, looking at all the metrics and stuff like that. On the other hand, my background is more on the prescriptive side. So I'm kind of working on all these column generation models that's kind of taking these counterfactuals and then taking it to its logical outcome of producing prices. So now we can do like an end-to-end thing, where we kind of say, what kind of impact does the choice of your teacher have on the final outcome as well, right? But we were able to kind of divide and conquer because of this, of the way this knowledge transfer occurs between the two models. So you could actually have kind of fairly specialized folks working on one and not worrying too much about the other side.
Okay. Because I always think that is important. Uh, is it's not easy working on big projects such as this by yourself,
Yes.
because that is just you may overlook, and there may be oversight of some angle.
Yep.
And but at the same time, when you have the different expertise having some say on the model, and I think this is a scenario when you go into the modern world of AI, is it
Yep.
becomes multi-layered, it's complex, it's across multiple domains of expertise. So
Yes.
the integration and streamlining within the team based on communication and constantly is kind of important. And you have a third factor, you have your client,
Oh,
because
absolutely. Yep. So they
they
keep us,
have to, yeah,
yeah, so they keep us honest, right? So they know what numbers make sense for what markets, right? So
exactly.
our test markets, they're very clear in terms of, okay, right, this price elasticity doesn't look right or whatever, right? They're able to spot those patterns right away.
Exactly. So
And
they're bringing that nuanced, more contextual references to you. So
yes,
you are
correct.
interpreting those and kind of adjusting and tweaking your models to make sure that when the bird is released from the cage,
Exactly.
it can fly in the right direction or fly as they choose it, they want it to take it, right?
Very true, very true. Yeah, I
So
mean, because you have counterfactuals which also have to work with other counterfactuals, right?
yeah,
Because
exactly.
you're generating prices for a variety of different customer segments. So they all have to kind of work together to improve operational effectiveness. They cannot be kind of competing or kind of cannibalizing each other.
Okay, so
So
that kind of takes me to the next thing, which is where we started this discussion just in a few minutes ago, is when you're handing this off and you're moving from theory, you have this wonderful model built based on counterfactual, you have these three layers, each tying according to you very nicely and smoothly to the other layer. But it is again based on counterfactuals. So
correct,
now we're going to test it in the market, right?
correct. Yeah.
So how did that model implementation happen? How did you validate, or did you have to retrain and iterate? So could you kind of give me a background into the actual enablement of this work that you've done?
Sure, sure. Yeah. So the first part, right, like I said, we were working mainly with historical data. So
Mm-hmm.
you kind of see very good results in back testing, but it's in a very controlled environment,
Yeah,
right? It's,
yeah,
it's just historical data. You still want to see how is it going to perform in the live, right? In the live implementation, what's going to happen? Are there some factors that we haven't taken into account? Are there anomalies? Right? So there's all kinds of things that can happen. So we work with the client to identify about 10, they pick like 10 test markets. You kind of try and pick those that are fairly representative of their right.
mm-hmm.
They're a legacy carrier, so we kind of pick markets that are representative of the different kind of markets they serve. So you say that, okay, I'm going to be generating these AI powered prices for this, but you still need something to compare it against, right? And you can never get a perfect apples to apples kind of comparison here, because you cannot do like randomized tests within a market, right? You cannot
Yeah,
start giving randomized prices to customers on your client side. So that's not possible. That's ruled out, right? So what we ended up doing was to set up a bunch of composite markets. So the airlines were able to, the client was able to figure out that, okay, let's take our, Atlanta to Dallas market. And they kind of looked at all the, variety of markets they were serving to find out which one market or even a composite of
mm-hmm.
multiple markets
Mm-hmm.
most closely matches this Atlanta to Dallas market. And they use that as kind of your control, right?
Okay, I
So
see.
they have
So
a bunch of pricing analysts who are monitoring the prices in all these control markets. So it is a bit of a bake-off in that they are trying to kind of use their manual procedure and their expertise to kind of set good prices there. And we are generating our prices here for
mm-hmm.
these markets. So the idea was to run this for a period of about 14 to 15 weeks,
Mm-hmm.
right? And then let's see how it goes. And then at the end of the process, we had to hand over the system entirely to the client, and they are going to run it on their own for a
Wow.
few more weeks, to actually double check and confirm, right? Because
Mm-hmm.
I think the first requirement in live testing, right, doesn't matter whether you're a client or you're a vendor, is you have to be skeptical.
Mm-hmm. Yeah.
There is going to be a
Mm-hmm.
lot of noise. It is a noisy environment,
Mm-hmm.
so
Mm-hmm.
you have to do a lot of kind of comparisons to make sure did you just get lucky, or is it really kind of statistically significant gain? So that is how this whole, yeah, that is how this whole process went about.
Okay, so now, of course, the drum roll, right? So what happened? What was the outcome of that 15
Right.
weeks of testing?
So, I always like the first 2 weeks because at that time you have no clue. Yes, your back testing looks great, but in the real world, right, it's you don't know what happens. So the first 2 weeks, as you can see, right, in this picture, right, it's okay. It was not negative, right, which was the main thing. Nothing, there's no red flags, nothing crashed, right. It looked okay. So we are kind of very heartened by that, right. The airline themselves had set a goal of, I think, 3 to 4%, 3 to 4 point improvement as a target. They considered that, right, to be kind of successful, right.
Mm-hmm.
And they even said even if you get 2 points, that would still be good, right? But 3 to 4 was a target that they had set, right? So once we got past the first couple of weeks and we kind of saw that, okay, it seems the hint is it is moving in the right direction. We got super encouraged by that. So
Mm-hmm.
we were able to kind of learn from the right. There's always weekly data refreshes that we were getting from the client. So we were able to bring the data back into our models, retrain it on a weekly cadence, and generate a new set of rules which would actually go out to their website,
Mm-hmm.
right? And for those markets, and customers would actually look at it. So it was literally right as live as it gets,
Mm-hmm.
right? But as you can see in this graph, over time, we were able to learn the customer response, right, better and better and better. So over a period of time, we were able to not only improve our accuracy, we were also
Mm-hmm.
able to widen the range of counterfactuals that we could now kind of start to offer, because we tried some new points, some didn't work well, some work really well. So your kind of model starts to shift to those good areas. So gradually, by the time we got to like the 14th, 15th week, you can see that the gains it got to more than like double digit range, right? Which
Mm-hmm.
was easily kind of double the target that they had set for us.
Mm-hmm.
And like I said, they compared it on every conceivable kind of control market combination that they could think of. And it actually performed positively on every one of those, which was really good for us.
So I want to go back to the black dots, which are your control markets, and that
Yep.
you had made assumption that it was a composite and it was
Yes.
a lookalike, right? Lookalike
Yep.
to where you were actually implementing it and you had a control that was similar to it and you were kind of
Right.
they were comparing it. So when you started making, so they went with the original plan of, but these are X number of composite markets that are similar to what you actually led to build your initial thing,
Right.
model on. So the whole framework was built around that. So is it right for me to interpret that as you go into the February, March further out, you are now seeing that control drop, whatever the KPI is,
Right.
that is actually reflecting the counterfactual, right? They're going to different other markets which may not have been equivalent to the composite where you actually trained on historically. Is that
So
what is happening there, or is it that's not my interpretation?
yeah, it's those black dots. Yeah, really, yeah, those are like a reference. That's
Mm-hmm.
exactly like you're right in that those are actually the control markets,
Mm-hmm.
right? So they typically represent like just a seasonal change, right? So the markets are taking into account that as well, right?
Okay.
So they are looking at markets that, again, right, not just in terms of passenger mix, the haul length, right,
Yeah.
multiple dimensions, right, but
Mm-hmm.
specifically, any kind of seasonal patterns that you are likely to see during the test
Mm-hmm.
period.
Mm-hmm.
So you
Mm-hmm.
kind of take all those into account when you identify these composite markets, which means that you take any pair of pilot and the pilot market, test market, and the control market, they kind of have very similar kind of cadence in terms of
Okay.
seasonality, right? Drop in
Mm-hmm.
seasonality, things
Mm-hmm.
like that. But remember that your control markets mainly have a static pricing policy, right?
Mm-hmm.
Whereas I can, all right, my model is kind of responding. It's looking at the shift in the customer mix. So it is able to detect when maybe lower prices are going to work better, when higher prices are going to work better. So it can make those kinds of adjustments that are not possible in the control markets, which are still following the legacy process.
Okay.
So the gain kind of comes from that. And you see these three metrics here, which is revenue
Yeah.
per booking,
Yeah.
the conversion rate, right, and the yield itself, which is the revenue per upsell. So you see that the main KPI, which is KPI 1, was kind of the main target, but you do see that the yield has gone up, and the conversion rate in terms of the seats sold did not actually change that much. Interestingly, the client actually liked the slight drop in the conversion rate because it means that not only are they making kind of getting higher revenue gain, they also have free upgrades to offer to their loyalty customers, and which in
Right.
fact is again a big deal for them.
Yeah, because with the same amount of seating, you
Right.
are optimizing around how many people are there. You don't have to
Right.
go and acquire new
Right.
customers, but you are optimizing within the availability of seats. Because if you
Correct.
pack the plane with lots of new passengers, then you're not able to give that qualitative upsell impact of
Right.
your pricing.
Right.
That's very interesting.
Yeah.
Now, I know when I don't think we touched upon the data itself, but I remember you telling me that you did not use um, the consumer profiles as such,
Correct.
right?
That's correct.
Because that is something you kind of avoided in a
Yes.
sense that you didn't want to make it dependent on the
Absolutely.
people, on the passengers of a certain segment versus the other segment.
Right.
So you abstracted that human piece element out of it, and hence a lot
Right.
of what I would say could be very difficult to
Yes.
to kind of take from one market to the other. So what
Right.
did you end up actually using to build the models or the algorithms?
Yeah. So yeah, like you said, right, it becomes very tricky when you start bringing in kind of demographic data, right? Those other kinds of things. So that is a very kind of strict no-no right from the client itself, because pricing always can be quite a sensitive issue. That's number one. Second thing is the criterion that can be used ultimately in the student is actually quite regulated, right? You cannot, these fares, like I said, all have to be published. So there are only a certain number of certain types of attributes that can even be used, right? You could, for example, use, okay, main cabin fares, as that is okay, that's accepted. You could use, journey attributes, right? Does your trip have a weekend stay or not? Is it a one way or a round trip? How many days in advance are you booking? Right. So again, going back to our Dallas to Atlanta. So you look at all the attributes that you see in your historical data for that particular market, and those kind of become the features on which you're kind of building these segments. Right. It also ensures that you kind of are not bringing in anything that could potentially be discriminatory. That's one. And the second thing is we also want to make sure that we're not just raising prices, right? So again, right, this is something, people have a right to be skeptical. Okay, this is a pricing application, it's a revenue kind of, you're trying to boost revenue, right? But you also have to keep public good in mind when you're doing this, right? So the interesting that happened is, right, we got all these KPI gains, but the average price actually came down a little bit, which means that a lot more people now are actually able to see upgrade offers within their budget, right? When you have a static price, in some sense, you can say it's slightly more unfair because it is out of the budget for a lot of people, whereas for others, maybe it's a steal, right? So by smartly kind of adjusting prices, you are able to get new people in, right? Especially when you have excess capacity.
Yeah.
So you're able to smartly reduce prices, increase prices, all without having any information about the customers themselves, any kind of personal information or anything like that. Right? You can still generate good economic kind of gain
Yeah.
without having to kind of getting start doing more personalized kind of stuff.
And what about seasonality? Was that part of your historical training?
Absolutely, yeah. So you can incorporate that. So there are two ways, right? You can incorporate that in your teacher model, number one, and number two, in your student model itself, when you're kind of you're jointly generating these segments and prices, you are looking at not just your current state of business versus leisure, right? Assuming you just have two groups, you're looking at what is it's maybe 60-40 right now, but when by the time you implement it and it goes live, it could be 40, 60. So you have to be able to kind of forecast and kind of understand what the future pattern is and price according to that. All right. So you have to kind of move towards a right. It's a moving target, and you have to kind of do that.
So one of the few last questions I have on this is, now you build this, you have learned so much from what you have built in the frameworks. Where else can this kind of framework be used, this whole counterfactual optimization and policy learning?
Oh, it turned out to be really valuable to us, right?
Mm-hmm.
So we have since, applied it in a variety of different domains. Semiconductor manufacturing is one. We've kind of working on tender pricing, which is pricing of kind of bids, open bids, right?
Yeah.
So we have applied it there. We have applied it to, as kind of to figure out how do you offer kind of promotional offers for like credit cards. And one that I'm particularly excited about is IBM's hybrid cloud. We're trying to do resource management. So you're kind of trying to see, as the load in the system goes up or goes down, right? How can you kind of come up with a policy to kind of optimize your resources? So we kind of applied it there as well. So it's been pretty exciting for us
Yeah,
to
I
kind of.
remember Marcus was feeling more excited from the financial, from the credit card offering point of view. So
Yes,
yes, he was
absolutely.
not here. Yeah, it seems like IBM will become its own biggest client for many of the products that are done. Because when I worked with
Yeah,
IBM, I too, we used the IBM, experiences and surveys to kind of better the product and the services that we're building.
right.
So it was remarkable what a large internal market, client market you have.
Absolutely. Yep,
Yes.
yep.
Okay. So towards the end, let me ask you about what your key takeaways are in terms of balancing AI-driven decision making with operational feasibility. What is your viewpoint? What is your perspective?
So I think with taking this dynamic ancillaries kind of project and the
Mhm,
live pilot as an example, there is a tendency to build extremely complex models that is in one shot going to go and optimize everything. But what seemed to work better here is the um, the baseline pricing, right? The policy that we implemented is a slightly zoomed out version in that it is proactive, right? It is not dictating to the client, these are the final prices. So it's giving you a baseline. The customer can still go and innovate, right? Because there's a lot of operational stuff that's going on, which our model doesn't try to handle, right? So
mhm,
it's kind of setting more or less a range that
mhm,
the customer can then kind of adapt and improvise in operations. So that became a very happy kind of marriage between something we do in planning versus what happens in operations.
mhm,
The second takeaway for me personally is that you can get a lot of economic gain by, right, not getting, hyper kind of getting hyper optimizing in terms of extracting every single feature out there, demographic. And because to me, that looked a lot myopic. I think you can be far more sustainable if you build more robust models. Again, right? Again, let the customer deal with the innovative part and the last mile thing, right? So we can use
Yeah.
our data to come up with kind of set up a broad policy. So that
Mhm.
seemed to work pretty well for us, and I think it's a good sign that you can take operations research models, impose all these constraints on it, and make
Mhm.
these models kind of behave well in practice.
Yeah,
Right.
and I think you're right. As long as I really like the way you approached it by removing and making it totally agnostic to the PII. So you are
Yeah.
kind of bypassing some of the ethical AI issues by doing that. So otherwise it's going to be a tough call.
Right.
That is very significant part of how, in credit, as Marcus had initially given example, is for
Yeah.
credit risk, you want to kind of strip away of anything that is going to kind of hit against all the regulations that you're going
Right.
to seek about a person,
Right.
age, gender, and those kind of attributes. So yeah, okay. So that was wonderful. So any last thoughts before we turn around and see if there's a question in the audience?
Sure. I think just the one point I remember was I think the word of praise we got from our client
Yeah.
So they are like very seasoned campaigners in analytics, right? They pioneered a lot of the stuff. So they said this was the first time they actually had an AI system work well for them in practice. So that was like a huge confidence boost for us. It made us really, really happy
Yeah.
that they actually came out, and they're very guarded with their praise.
Yeah.
So, we're very happy to hear that from them at the end of
So
the project.
what do you think it was the chemistry that clicked for any future AI leaders out here listening in?
So I think it is you have to bring in some domain expertise, right? You have to listen to your client, right? You have to allow them to question your findings, and at the end, you have to be skeptical about we have to be very skeptical about the results. I think just spending a lot of time on setting up the live test makes a lot of difference, because when you're just working with data sets, it is not too difficult to show gains. But the live test part to me is very crucial, where you have to get a lot of input from the client. And likewise, the client also listened to us, right? When we were kind of deciding on markets, we showed them, okay, these markets maybe look similar in terms of these attributes, but their behaviors are very different and stuff like that. So there was a lot of kind of exchange of ideas, and a lot of debates, healthy debates, to kind of figure out, right, how do we set up our test so that it should work well in the end, right? I mean, it should be a fair test that gives us the truest possible picture amidst all the noise.
Yeah.
So, yep.
Okay. Well, thank you so much. Let's see if we have any questions from the audience. Go
There is one question.
ahead,
Open.
Raj.
I can read it out, or
Yeah, you can read it
yeah.
out. Yeah.
Yeah, so this question is from Alan Thorpe. The question is the model for dynamic pricing to upsell ancillary airline products based on a perfect customer uh, brackets completely rational, well-informed individual who always maximize value, or a truly imperfect consumers?
So
I'm curious how there is second part of the question. Maybe I'll ask that later once you finish it.
it's actually a great question. The reason being that there are a lot of pricing models which we have worked in the retail space, for example, where you do make assumptions on customer choice and how they choose between buying versus not buying. So this model, interestingly, the teacher model or the teacher models we have worked with are kind of just entirely data driven, right? It is not making any assumptions on customer behavior at all, right? So you can think of these as working with millions of data points, very kind of large machine learning models upfront, right at the start of the process, which is just looking at the buying patterns that is present in the data itself, without making the assumptions on the rational purchase patterns of customers.
There is a second part of the question, which I'm also curious to know how the economics of these pricing models will need to change with the growth of agentic AI. Assuming this technology will be able to consistently achieve the best choices based on rationality, the combination of services, maximization, and well-informed decisions.
Okay, so it's a question that's looking ahead. So 2025 is kind of the year of all these AI agents, right? So at IBM also, of course, we are working on these problems. So interestingly, we have actually started the work like maybe a year and a half ago, where we are actually able to take this this optimizer, and we are actually making it a part of the agentic framework. So we are actually now making this, we're taking literally the core technology out of this, so not just pricing. So we're taking this core teacher-student kind of part out of it, the core algorithm, right? And that is now being put into this agentic framework. So uh, different departments and either within IBM or even external clients, hopefully in the future will be able to take advantage of this. Yeah, so the scale is quite right. How much it can scale is actually a very, very interesting question. It's got a lot of potential, that's for sure.
So would you probably frame it in the sense that the tools that an agent will be using would draw upon the essence of your model and the assumptions
Correct.
so that it is calling out, the agent is calling out to this optimizer agent to complete the task and give it
Correct.
feedback, and it's able to do this with multiples and then give you
Correct.
that kind of a single view
Absolutely.
agent
Yep.
model.
Yep.
Okay,
Yeah,
great.
a lot of possibility.
Yeah, a lot of possibility. Thank you. Raj, was there any other question?
That's all the questions
Okay.
from the audience we have.
Okay, great. So this was really very interesting, and I think we explored a lot of different aspects. And yes, going to an agent model, it's going to be very interesting to see what people now can see as the agents operating on the top, but at the bottom there is still core models, AI models, optimization models that are really doing the hardcore work.
Yep.
So
Absolutely.
so it
Correct.
is still brains over matter.
I agree. I agree. Yeah.
So anyway, so thank you so much for your time, Shiva. And so unfortunately, Marcus couldn't make it to us, but thank you very
Yes.
much for participating and sharing your insights and your project work. So all the best. I
Absolutely.
look forward to it. And for the audience, we'll be working with the team to convert this into an article in the Informs magazine, so you can read more and learn more about it as well out there. So thank you all. Thank you for
Awesome.
joining us.
Awesome. Thank you so much.
you. Yeah.
Yep. Thank you.
Okay. Recording. Stop.
Thank you.
Thank you. Hey, thanks, Russ.